So, Vanakkam. So, we will continue our lecture on engineering seismology. So, we have been discussing about the different the tectonic setting, a major, okay, the major three category. So, we have discussed. So, with respect to the past earthquake and how the sequence of the earthquakes are happening, and so we have been talking about that. So, now we discuss a individual earthquake, some of the selected. I am not going to discuss everything, but if you want to see the history of the past major earthquakes, actually you can go through this book. So, which is one of the classical book in the history of Indian seismology, because most of the books, if you see, even earthquake geological engineering or other major books which generally referred from the western countries, okay, where you can see very little information gone into the book with respect to our country. Okay, so which is very important, particularly on seismology point of view. So, this was the book written by scientist so Rao, okay, so where his name is actually Ramalingeshwara Rao. So, he was actually extensively worked in the NGRA on seismology. He published several papers, okay, even some of our discussion we might have quoted Rao et al. Okay, so actually he did seismic activity on Indian scenario. So, where he has given a broader, okay, and as well as the in detail, in depth, okay, information about the several earthquakes in India, isoseismal map and source activity. So, whatever studies have done as on this book published is compiled. Is one of the valuable books those who want to know about the more about a local seismic activity in the region. Okay, they can refer this book. Okay, so where he also used to call me and discuss about this book. He has supplied this book actually free of cost for the teaching purpose, where I used to take many of the notes as well as the reference from this book. So, what we are going to discuss, some of the earthquakes already printed on this book. You people also can buy this book if you are planning to work further on seismicity related areas. So, as we told that the individual earthquakes plays a major role in deciding several things, so which we will be discussing in that. So, the first let us talk about the great earthquakes in India. So, as we have seen that the entire Indian subcontinent, okay, has been divided as a three major category. So, the Himalayan and the Gangetic plain and peninsular sealed. Okay, so this is what you can see. So, this is basically the entire thing has been called as a Himalayan. Okay, so then this is basically called as a peninsular India. Okay, so the in between part, okay, this is the Gangetic plain. Okay, so the Himalayan arc convexed, okay, southward and fronting of the alleviated depression of the Ganga plain. So basically this geological wave formation, okay, and the erosion all causes a Gangetic basin soil. Okay, so Ganga plain is called. Then in front of Himalayan arc foothills, okay, so Sivalal keys and then the territory, so metasediments. So those are all the some of the features of the Himalayan belt. The Ganga plain separates the Himalayan from the peninsular India. So basically the peninsular India, more or less the rock, okay, is where you can find very hard rock, okay, at a shallow depth. Shallow depth means maybe about 100 meter, okay, within 100 meter or about 100 meter. So then the Himalayan belt also you will have similar to that rock in the most of the places in the shallow depth. But in between this Ganga plain, you have a rock at a very deep level, starting from 100 meter is the minimum depth, and then it goes up to 6 kilometer where the rock. So that means so much of thick soil deposit found in the Gangetic plain. Okay, so that is the one of these. So the Archean, okay, rocks are over more than half in the peninsular India. Large part of remainder covered by the basaltic flows of Deccan Trap. Okay, so these are the some of the geological, this one where you can see the distribution of the geological formation and then the valleys and basins, okay, all those the larger geology map. Okay, so 5 great earthquakes, okay, we are talking about the great earthquakes. So great earthquake means earthquake magnitude above 8. Okay, the earthquake magnitude above 8 is called as a great earthquake. So about 5 great earthquakes are occurred, okay, in India. So the 5 great earthquakes, then most of them are occurred in the belt. Okay, so the Himalayan belt. So this has actually in the 100 around like last 100 year plus years. So since 1897. Okay, so there are 3 in Himalayan arc like Kankra, Bihar and Assam, 1 in northwestern peninsular shield, the Kutch one also, which is very close to 8 magnitude, or the oldest one claimed to be 8 and above, and 1 Shillong plateau where 1997. So these are all the earthquakes are having 8 and above magnitude, which is called as a great earthquakes of India. So the Himalayan belt come into existence due to the collision of Indian plate and Eurasian plate, with Indian plate underneath a Eurasian plate since the Creatic age, the rock formation age. At present, the rise of Himalayan is taking place at the rate of 5 centimeter per year, which is the rate of where the plate is moving. Our plate is moving with the speed. Similarly, the rise of Himalaya also happen. Such a collision has triggered many devastating earthquakes in Himalayan belt and a different segment. At present, due to building up strain, seismic gap has been highlighted by many researchers, which says that the possibility of large seismic event in the central seismic gap Himalayan belt in the near future. So this seismic gap concept exists since last 30 years. Okay, the Billam is one of the scientists who claim that the seismic gap can explode anything, but fortunately until now we are not experienced any great earthquake. So that is the one thing we should thanks to the God, but I don't know how long it will continue. As I say that the strain building up, okay, is the one of the major cause of earthquake. So the strain has to be released one point of time. It may happen in the lifetime of our period or your generation or your next generation, we don't know. Okay, so but the building up strain always causing a earthquake, okay, which is a very significant in the Himalayan belt, as there are many earthquakes are occurred 500 years, 300 years, 700 years before, not a recent past. Okay, this alarm a seismic vulnerability of the Himalayan region adjoining the Indo-Gangetic basin. The peculiar thing is that any earthquakes on the plate boundary, okay, since the highly populated urban settlements are then the Gangetic plain, so any earthquakes are occurring on the plate boundary also affect the Gangetic plain settlement. Okay, so starting from the Uttarakhand and Haryana, UP, Bihar, okay, so this side West Bengal, okay, then the Bangladesh, and then even further like a part of the Orissa. So these are all the places where one can expect this kind of devastation due to the any big earthquake in the seismic gap. Okay, so this seismic gap because occurs because of the Himalayan action, okay, which where the two crusts hit each other. Okay, so you can see that this is actually the continental crust. Okay, this is again the continent crust. So this hitting each other, there is a oceanic crust. So in between it's a sandwiched this. So this lithosphere movement hitting up both actually, as we have seen that this was once moving at the speed of 20 centimeter per year. So now because it hit a Eurasian plate, the speed has been reduced 5 centimeter per year. So both are hitting basically, the hitting form a many hills. Okay, so this hills basically below this hills there are many segment and fracture, okay, a fault zones are exist. So which will keep releasing the energies, okay, whenever it exceeding its capacity. So this is because before forming that Himalayan hill. So this is the Indian plate, as we have seen that this is a like very old rock. So where the carbon dating the rock indicated that that particular place where 2.5 million years old rock was there. Then followed by this is the Eurasian plate where the ancient oceanic crust is there. So this is actually the tip of Indian plate at the time of like the both of them are hitting, okay, about 2.5 million years ago. So then after that it slowly start pushing each other, and then because of this heat there is a lot of disturbance, okay, in the geological formation and tectonic activity. So this point now here from here it is moving like this, you can see. Okay, so there is a lot of fracture and then the formation and then joints. Okay, so these are all moves in the age of geological period, okay, which you cannot physically see yourself what happens. Okay, but in the longer run, okay, so with the 5 centimeter per year, so if you see for the your career up like the 50 years, so you can see only a 250 centimeter growth or variation. That is what people are keep noting down, and with the evidence of accumulation of large amount of this kind of data, people proved that this is a action it is taking place here, which is necessary to be considered for any future seismic hazard assessment. So this is the sum of the classical, okay, earthquakes and their strain level released, the amount of strain released. So there was about 2005 earthquake we talked, so this one. So then the Kashmir 1985, the Kangra earthquake, and then Kumanu earthquake and Nepal, and then this is again there was some old earthquake, so 1893, so the BC, the Bhutan, so the Assam earthquake. So this indicates more or less a magnitude of earthquake, okay. The bigger in size means a greater earthquakes or larger earthquakes are occurred. Smaller means it's a smaller earthquakes are occurred. So there are segments, okay, so where you can see these are all the segment there, the moment the slip is taking place so much, but it is not released that energy, the moment is taking place but not released. So those are all the places where this is actually called as a western seismic gap, this is the eastern seismic central seismic gap, this is the eastern seismic gap. People believe that these places there may be chances of bigger or greater earthquakes in the future. So that future, again I told you that it very difficult to precisely tell what is the future. So as I told you that this seismic gap concept has been introduced and discussion in the last 20-30 years, okay, but so far as such now nothing was happened. Somewhere we should be happy about that, okay. So but at the same time it may happen any time, okay, which may be happen during our lifetime or next generation, as these earthquakes are having very large return period, okay, 500 years, 300 years, precisely pinpointing when it will happen will be very difficult, okay. So it's a better ways to prepare ourselves by understanding this earthquake, what happened on this earthquake, how it is damaged, how much extent it damaged. So one of the classical example, the great earthquake which we start was actually the Kutch earthquake. The Kutch earthquake was occurred 1819, okay, it's called as a run Kutch or Kutch. So that occurred on June 16, okay, in the 1819, northwestern corner of peninsular India, considered to be the largest event in the peninsular India. So this is the largest peninsular earthquake, okay, so in the world. The first for which the crustal deformation was quantified. This is also a crustal deformation was quantified by doing a detailed study and modeling. So the maximum intensity reported on this was actually 11 on modified Mercalli intensity scale, were reported by the Oldham actually, based on some report and other things and all. This earthquake occurred before the invention of the seismogram, you can see. So that means there is no way you can get a seismic record of this earthquake, okay. So based on the reported intensity, the Kuttenberg-Richter, okay, assigned a magnitude of 4.5. This is basically failure seismology study people have reported. Here you can also note that 8.4 is not a valid Richter magnitude. So I hope you are all aware, up to 7 only it is valid, beyond 7 it saturates, but still the literature people like reported those things based on the some kind of paleoseismology studies understanding. The review was stable continuing earthquake and assigned, okay, magnitude of 7.4 for this, 7.8 for this event. So because of this 7.8 and 8.4, still its ambiguity what was the magnitude, but it's since it is caused extensive damage and intensity of 11 and above, so this can be called as a great earthquake. A remarkable feature of this event was creation of the 80-90 kilometer long and 2-3 meter elevated tract land, which was I told you that known as a Allah Band or a dam of God. Okay, so there was a projection above the surface. Okay, so such kind of projections was created with the length of 80 to 90 kilometer long with 2 to 3 meter height. Okay, so in between basically the Pakistan. Okay, it's actually the fault scrap appeared run up Kutch close to the international border between the India and Pakistan. Okay, so the RAN means so the uninhabited salt flat that are neither sea or nor land are flooded frequently. So that's the RAN. So this is called as a Allah band or dam of God, where it is projected above ground 2-3 meter, like some kind of elevation are created in the so long, which was naturally created. Still this is exist. So if you had a chance, or if you are from that region, you can go and see how it is exist. As I told you that many of the beauty in the world occurs due to the earthquake. Okay. So a deep valley, a nice hill or slope and river, all those things basically geological formation. This geological formation happens by landslide and earthquake. So basically the earthquake is one of the event which basically carve a world into the beautiful shape and terrain. Okay. So the 11 watt intensity says the total damage, okay, few if any structure standing, bridges destroyed, wide cracks in the ground, waves seen on the ground. This is the description given for the intensity 11. So this was the epicenter of earthquake was given. This is the estimation based on the fellow seismology. Okay, Chandra 1977. The loss of life was about 1,500. They estimated, or it was reported in the past they have taken. Earthquake was not felt all over the country. Those 1897 or 1834, it was of course violent in the Kutch regions. Okay. So this was the observational, the literature. Due to lack of instrumental data, exact source parameters are not known for this earthquake. So there are some damages reported this earthquake. Okay, the Grant 1891 report is there. No source mechanism was reported. However, the false dislocation model 1819 event and inferred that fault length will be roughly 95 km, width will be 16, strike will be 290 degree, dip will be 30 and MW will be 7. This was the some of the model studies based on the data collected, and they try to get this information. They also suggested that epicenter should lie to the north Allahabad based on the geodetic measurement of Billam 1998. So other hand, the inferred fault dip so much, reverse slip and then down dip so much. Okay, so there is some slight difference, but these are all based on some kind of estimation and assumption. So there may be always the right and wrong things can be discussed in the desk. Okay, but overall these informations are arrived by modeling. That's the message you can get, because when we are talking about the seismological modeling aspect, particularly synthetic ground motion, simulation of synthetic ground motion, we have been talking the importance of the source parameters. No? So those are all the parameters based on the similarities it has been arrived. The ground excavation in the several area reveals large multiple liquefaction features are across cutting nations, different stratigraphic levels, recurrence of magnitude of 7.5 and above, multiple segments of region has been suggested. So this Rajendran et al., Kosala Rajendran, I was keep telling, failure seismology study they do. So those people basically done this kind of excavation, and based on the liquefaction features, they reported that this may be a kind of magnitude one can expect on that level where there is no such measurements are available. So the another great earthquake is Shillong earthquake. The Shillong earthquake was the great earthquake of the world. So June 12, 1897 earthquake, Shillong Plateau hold a very predominant place in the seismology, because this was the one of the oldest well documented earthquake. So Dr. D.R. Oldham, when we are discussing about the seismic instrumentation, we told about this Oldham studies and all. So the head of Geological Survey of India director and personally carried out most of the investigation of this great earthquake, loss of life. Okay, about 1,542 people compared the magnitude of earthquake. So there so many people have died actually. Okay, the loss of life was fortunately less because of the earthquake occurred on evening time. You can see. So generally evening time in India, traditionally people sit outside the house, not inside the house. Okay, so even those who are living in the villages and all, those days there is no power. So generally what happens, when sun sets, people will come back to home before sun setting and then try to finish a dinner, okay, before sunset completely goes off. So because of that, evening time generally people used to play outside and sit outside the home, make cooking or discuss something. So that was a favorable reason where less number of people died. Okay, as I was telling you that the time of earthquake also plays a role in deciding the devastation of the particular earthquake. The epicenter was reported to be so much based on the field observation. Okay, and the maximum intensity 12 on MMI scale, and this one the Oldham report also says damage property had been very great within a area about 30,000 square miles. Okay, all the bricks, stone buildings and practically destroyed. You can see that 30,000 square miles area it has been affected. Okay, such a very big large extent area which used to be noted, okay, which is very important. Okay, when we are talking about the selection of seismic steady area, these informations are useful. That's why I am discussing the detailed about this earthquake. The ground rocked violently, that was impossible to stand. That means people felt that it's like standing in the running vehicle. So rumbling sound, visible waves and seeches are observed. Seeches means the waves, tsunami kind of waves in the lakes close to water body are the seeches which we have discussed. Okay. So the 12 says total damage, waves seen on the ground, object thrown up to the air. So all the object in the ground was thrown up to the air. Those kind of the definition given for the intensity 12. Fissures are abundant over a whole area which may be due to the liquefaction. Secondary effect like ejection of water, sand, rotation of pillars, raising up river height, crushing of soil which houses sunk were reported in the epicenter. These are all basically the liquefaction phenomena, ground deformation phenomena which has been reported and evidence has been collected. It was also first strong earthquake in the country which was instrumentally recorded outside the country. So where this earthquake was basically recorded some other place in the world. Seismogram which recorded is 1897 earthquake, however were not modern type, so it was difficult to use record to determine the magnitude. Only the earthquake was recorded, but it is not very useful. It is a analog seismometer. As you know that 1880 only seismometer was developed. Those time this was analog in nature. A detailed study large global earthquake Gutenberg Richter, okay, assigned magnitude of 8.7 for this. So the Gutenberg Richter basically worked out based on this data. He assigned magnitude. This is the assigned magnitude. So the comprehensive damage report of earthquake given by Oldham based on damage survey, other evidence like upthrown boulders. Oldham 1899 reported that acceleration resulting from the 1897 great earthquake exceeded the gravity. That means more than a G. More than a G. So widely accepted by the modern seismologists. So there was evidence that surface fault called Cheng-Drang fault in the epicenter area which extended so much length thrown up to 30 feet crystallic rock. Okay, so this is the fault they believed that which is responsible maybe caused the earthquake. The largest dimension of the mesosysmal area was reported to be 160 miles which is close to 230 kilometer with the highest intensity of 12. So that means this area, okay, the intensity of 12 is basically 230 kilometer radius. Okay. So the based on the Oldham detailed report, okay, Molnar 1987 suggested that the length of rupture may be around 200 and plus or minus 40 kilometer rupture length it must have taken place. The southern edge of rupture was more likely the southern edge of the plateau than a south of it. Okay, so the possibility of rupture extent beneath the Himalayan was not ruled out. Okay, this was the some of the observation they have done. So as we have seen that any intensity 5 and above is always interesting for the engineers. So with that this one, if you see this is your roughly 90 is your epicenter. For example, this is you take it as a epicenter. Okay, then the highest radius, see the highest and smallest radius. So if you roughly take that 82, okay, so which is 90 to 82, how many degree is about 8 degrees. Okay, so if you take roughly the each degree is 110 kilometer, okay, the distance, okay, the degree to this roughly. So you can see that about 880 kilometer where the damages are extensive. The intensity of 5 and 6 is a concern for the engineer. So much area it caused the damage. Okay, it is from the evidence from the past earthquake. So these informations are very useful. We will be discussing this when we need in the future classes. The another earthquake is actually the Kangra earthquake. So this is the well documented earthquake which occurred in the Himachal Pradesh on April 4, 1905. The epicenter was reported to be this location. So initial magnitude estimated ML 8.6 and the revised magnitude of MS 7.8 plus or minus 0.005. So the Ambrasi and Douglas 2004, their loss of life was maximum, about 19,000 people died. Maximum intensity reported to be the X on the mm scale. Isosysmal were oriented along the main boundary trust Himalaya. Two zones of high intensity with intervening regions of low intensity were identified. So one in Kangra area and other in Dehradun. So this earthquake basically caused a failure pattern which is unique in nature, where the higher intensity reported here as well as reported here. So here also you can see that the 6-7 intensity, for example this you take roughly the 71, maybe the 76 or 78 I think. Okay. So you can see this distance. So this will roughly give you a degree conversion and the possible distance damage. Okay. So similarly this distance. So the highest damage one can expect, what is the extent it expect. So this is the another classical example where the soil, the modification of the wave due to the local geology. You can see the higher intensity here, higher intensity here. Here may be the urban settlement, because of that the intensities are higher, people are reported, buildings are damaged and wave modifications are seen visually. Okay, those are all the things. So the another earthquake is the Bihar earthquake which was happened on 1934, January 12th. Okay, so well documented by the Doon, okay, 1939. The seismologists of National Seismogram Station, India Meteorology Department and Global Seismic Station made possible to locate epicenter more or less accurately, to assign a magnitude of again M84 and then the focal depth of 20 to 30 kilometer. So these informations are very important. We will be taking this appropriately when we do the seismic hazard analysis. So the extent of the mesosysmal area was about 120 kilometer and 30 kilometer wide. Two mesosysmal spots separated almost 150 kilometer. So the Mangar east of Patna, Bihar, south of other at Kathmandu, Nepal and the were identified. From the distribution of damage reported by the Rana and Nepal by Don, so India, the Pandey and Malnar showed that damage was greatest in the lesser Himalaya and eastern Nepal. So these are the places where high damages are reported. So maximum intensity was reported to be the 10. The loss of life was about 7250, in Nepal 340. So about closely, so it is about more than 10,000 people died due to this earthquake. You can see this earthquake and then the damage distribution and then the epicenter location. Okay, so where you can see the, this is basically a spot. Okay, so this is the 7 intensity. So you can basically define this radius. Okay, you can see this is almost close to 76, 76.2. So this is around 84.2. So you can see like more than like so 200, 300 kilometer where the damage was extended. Okay, the Sieber and Armbuster, okay, 1981, inferred that slip occurred on the nearly flat plain lying beneath the Indo-Gangetic basin. Okay, so this was the first earthquake where the ruling out the source below the Indo-Gangetic basin. So Pandey Malnar assumed that epicenter beneath the Himalayan, that south of ranges commonly believed. Okay, so then the Sen and Malnar relocated the epicenter which lies within the area of high intensity zone. Okay, in the seismic zonation map. So the another earthquake is 1890-50 Assam earthquake. This is the one of the few great earthquake which instrumentally well determined magnitude of 8.9. You can see the magnitude was reported here, basically a surface wave magnitude MS. Okay, you should remember. So now you can recall why we studied all the history of magnitude development. Okay, how to assign that magnitude, how to estimate that magnitude. On August 15, okay, so about 7 o'clock, okay, 7 like night 7 o'clock, 40 minutes local time, the earthquake occurred northeastern boundary of Assam. The epicenter was reported to be this region, and intensity of 12 has been reported by Tandon. Okay, so earthquake caused about 1052 casualties, was more damaging than the property losses than the great earthquake of 1897. So USGS determined the epicenter location of so much, okay, so which is more or less similar, and the focal depth of 20 kilometer. So there was no strong motion seismogram station affected area to calculate the acceleration. So even though the India established station, okay, in during the after Shillong earthquake around 1990s, but still we don't have many station. We have only 2-3 station up to 1960s. So that's why these earthquakes are not recorded in India. An acceleration of order of 0.5 G was however estimated from the damage survey of the epicenter. So as he told that if you have the intensity value, you can convert it to G value approximately. There was a relation exist between these two. Okay. So the foreshock and aftershock was reported by many researchers. Okay, so then the fissures and sand vent occurred. The liquefaction was reported. Railway lines and road suffered the damage. So this was the first earthquake talk about the road damage and railway line damage in the India. So you can also see the location and the damage distribution reported. Landslide was observed various places. Tragic death reported North Lakshmipur, where the 9-year-old girl was caught in the fissures which had immediately closed up, burying her alive. So there is evidence that, okay, so there was the opening up or the fissures, sand boiling, where the people have basically gone inside the sand boiling. It's very tragic accident. That was basically when you have the big liquefaction. Okay, that has to be this. So the seismic hazard analysis or zonation of this area need to be account all these things. They need to consider this as a useful information to estimate a future hazard in this area. Okay, that is one of the need. That is why I am discussing this in detail basically. So the another earthquake, so there are two earthquakes which we are going to discuss. Mostly these earthquakes are in the southern part. So the one is the Kilari earthquake, which was MB 6.3, occurred on 1993 September, Latur district of Maharashtra, central India, killed about 7,500 people. So occurred middle continental shield region, low seismic activity. Local geology area observed, okay, the late Cretaceous Eocene basalt flow referred as a Deccan trap. This makes it difficult to recognize geological surface fault could associated with the Kilari earthquake. The epicenter was reported, this is the one. Okay, so then the focal depth of about 8 km. You can see that this earthquake is very shallow compared to the earthquake what we discussed. That is the one of them. The aftershock investigation carried out making a temporary micro stations by the GSI, 140 aftershock well located GSI network. Epicenter was shown in the next page, we will see. So this information you can get it from this paper which I read and summarized for you. So this is basically the location, okay, of the different earthquake in the peninsular India. So okay, so where the Latur, okay, so Latur, and then the earthquake what we are discussing basically the Kilari, okay, so it's called as also a Latur earthquake. You can see this earthquake. So this is the earthquake. So this is the beach ball. We talk about the beach ball. No, you can see the beach ball. So these are all the different beach ball which is published for the peninsular India. So maybe this information is also useful when you want to model synthetic ground motion at particular location. Map showing the epicenter of major tectonic and a significant earthquake of M ±6. So okay, the India, the recent damaging earthquake shown by star symbols like this earthquake. Okay, so this earthquake. So then this earthquake, Jabalpur earthquake, these are all the recent earthquake after 1950. Okay, some of them are very old. So this is actually again the Koina earthquake. Okay, so the dark area indicates zone of compression. Okay, so in the beach ball, and blank area zone of dilation, fault movement in the shown by the arrows. So there is a arrow which shows a fault movement, how it moves. You can see the arrow which shows actually. Okay, so where you can see the how the fault plane are moving. So they defined a fault like, so the Narmada San Narmada lineament, so which is this one basically. Okay, so then the Tibeti lineament, so then Kutch mainland. Okay, so fault, this one. Okay, Indian plate movement from the Charles. So these are all the some of the geological evidence and data collated together and prepared this kind of maps. Okay, so particularly the Killari earthquake where we have been discussing. So this is the epicenter map of Killari earthquake. So you can see the epicenter is somewhere here. So which is around, so 30 to 45, 15 degree. So it may be around close to like 40 or 38. Okay, so then you can see the intensity of 7 where this is the level, the distance. Maybe you should take like this. Okay, so this was basically 18, 19, okay, so or 16, and then this angle. So if you calculate this, you can see this distance are quite large, okay, when compared to the size of the earthquake. So map showing the epicenter of Killari earthquake. So aftershock on solid circle indicates a deeper 60 feet aftershock and small shallower shocks. So the high intensity zone 7 is shown in the curved line. Okay, this is a map was prepared by the GSI. So the fault plane solution, lower hemisphere, the main shock, seismic tomography image, depth of 6 meter shows there is a difference in the geological materials like rock, you can see. Okay, star indicate the main shock, P wave contour show the contour code. Okay, so the P wave velocity which shows here your material stiffness, okay, the compressibility index kind of things which can be easily. So almost all the epicenter are located within the mesosysmal area. So the intensity is 8, most of the aftershock 70 shallow region, depth was around 6 and 6 to 15 kilometer, 2000 seismic arrivals collected, the P wave and S wave they have taken, and they try to understand the source nature, okay, dilation, contraction, getting up source parameters, all those things they try to understand using the aftershock data, okay, which was one of the classical information people have done. Basically the GSI, then the NGRI, okay, they have done extensive studies on these earthquakes and reported. Even you know that the seismic code was revised after these earthquakes, okay, where it was elevated from 0 to higher level zones, okay, that was this one. So this is about the individual earthquakes, its damage distribution, which will be useful to understand further seismic hazard estimation related studies, collect a data for that. So with this we will close this class. So thank you very much for watching this video. So we will continue our discussion on the Indian tectonics. Okay, right now we have seen the seismicity. We continue our discussion on the Indian tectonics from the next class onwards. Thank you very much.